We wanted to prototype as soon as possible, so the selection of particle board assembled with screws for the body allowed us to quickly and cheaply try new things. Tank treads were chosen due to their stability, ease of design, and ease of control at the cost of agility, because completion is our main goal and the speed of the run is secondary.
The robot captures the video and streams it to the base station. The base station opens the port and receives the data. When the data arrives, the base station puts it into the buffer. When the buffer fills, the video is streamed back to the driver.
We have the Raspberry Pi embedded on our robot, which hosts the server. For this, we chose to utilize the Python programming language as our language of choice.
We use the zero-tier software to assign static IP addresses to both the Raspberry Pi and the base station. For our server, we used a client list model for its ease of use.
So the robot receives commands via the server and decodes the message. This message is a composite of several different button states from the Xbox controller to control various portions of this robot. For example, you hit the right trigger, you pull the right trigger in, or you pull the left trigger in, and the robot will either go forward, this way, or reverse, that way. Hitting an A or a D button will cause an arm, which is in production, to raise or lower.
So for the electronics, everything's fed from these switch mode power supplies, which we made custom. They come in from the battery over here, and they are routed through to both of the PWM controllers and to the Pi itself. The motor supply is drawn from the battery itself because it's 12 volts, and we want to draw as much power as it needs. There's two PWM controllers. One of them is running at 50 hertz to keep the servo PWM at about 20 milliseconds, and the other here is 1600 hertz PWM for both the drive motors. The PWM for the 1600 hertz feeds directly to the motor controller, and the motor controller itself handles direction using a high or low call from the Pi. Everything's a bit of a mess right now because it's still a prototype, but we're working on a Pi hat that's going to sit right here on top of the Pi, as they do, and it will clean up a lot of these jumper wires.